Hello, and welcome to this panel discussion about interacting with automation as part of our Realizing the Potential of Industrial Robots series, sponsored by Rockwell Automation. My name is Katie, and I will be your Global Spec moderator, and I would like to review a few housekeeping items with you before we begin. Please take a moment to familiarize yourself with the operation of the user interface for today's webinar. The large window with the heading Presentation in the upper left is the primary window for today's webinar. Just to the right of the main presentation window is the speaker bio window with background information on today's presenters. Just below that is the Q&A window. At any time during the presentation, you can enter a question into the box in the lower section of the window and click Submit. Your question will be placed in the queue to address when we get to the Q&A session. At the bottom of your screen, you will see additional buttons to enhance your webinar experience. To see what a particular button does, just place your mouse pointer over it and a tooltip will appear with a description of the button's function. Now I would like to introduce our moderator for the Realizing the Potential of Industrial Robots series, Edgar Sauter. Edgar is the Senior Director of New Product Technology at CSA Group. He and his team look at the technology horizon for new developments and applications that could present opportunities for CSA's test, inspection, and certification business. To read more about Edgar or any of our presenters today, please look at the speaker bio window right next to the main presentation window. And with that, I would like to pass things along to Edgar to lead us through today's discussion on interacting with automation. So Edgar, welcome to today's event.
Thank you, Katie, for the introduction. I am Edgar Sauter, Senior Director of New Product Technology at the CSA Group, and I will be moderating this panel discussion. So, configuring robots and getting information from them has never been as easier as it is today. These have changed the way companies automate their processes. We will discuss this topic in this panel discussion today. And for that, we have put an excellent team of experts to cover it. So with us, today we have Aaron Prather, who is the Director of Robotics and Autonomous Systems for ASTM International, where he oversees standards development, training, and workforce development efforts and R&D funding. Aaron has written numerous articles about robotics and the role and impact on workforce development. He is on numerous boards and committees that develop curriculum for robotics training. We also have with us Mark Anderson, who is the head of robotics and automation products at Comau. Mark is a business unit leader with more than 20 years of experience in the robotics and automation industry. Mark is driven by building new business, developing new relationships, and solving problems. We also have with us Hitam Mansouri, who is a business manager for servo motors and integrated motion technologies at Rockwell Automation. He has more than 20 years experience in the field of motion control and industrial automation. He holds a degree in electronics and automation from the Haute École Leuven in Hainaut, Belgium, and a master in applied computer science from the Vrije Université Brussels, also in Belgium. With us today, we also have Dylan Phillips, who brings 34 years of smart manufacturing experience. He is an advisor to SME's Smart Manufacturing Advisory Committee, and he's also an accomplished speaker in IoT, AI, robotics, and AR and VR. He is also an entrepreneur and has served on the board of directors or as an advisor for multiple technical committees. And we also have with us Brian Garth Davies, who is a consulting engineer and roboticist with experience in various industries and applications. He has hands-on experience developing and deploying robotic arms, mobile robots, cobots, and more, along with a master's degree in mechatronics from the Stellenbosch University. Well, Aaron, Brian, Mark, and Dean, and Hitam, thank you very much for being with us today and sharing your knowledge and experience with our audience. So as we were talking, sending commands to robots and getting information from them used to be a really, really cumbersome task. But new developments in digital technology as well as communications have improved that task. Like now that particular expertise, special expertise may not be required. So those are the topics that we will discuss today, and how is it done and how companies can take advantage of this. But before we start, let's take a short moment to acknowledge and thank our series sponsor. So Rockwell Automation is a global leader in industrial automation and digital transformation solutions. Rockwell's inherited expertise in industrial networks, sensing technologies, and digital software means it is one of the preeminent authorities for everything related to smart manufacturing. For more information, visit rockwellautomation.com. This webinar is hosted by Global Spec, the world's largest online destination for industrial product sourcing and engineering information. Well, now, without further delay, let's start our conversation. So I would like to start with a very generic question, just for the benefit of the audience that's new to this topic. And I would like the audience to know or have a sense of how complex used to be the labor of configuring robots and getting information from them, and how that has evolved to the point where we are today. So who from the panel could help us with that?
Yeah, Edgar, I could have a go at expanding a bit on that. So I think you touched on it already, where you were referring to how in the past we would really have specialists and, even like a team of experts involved with setting up robots and programming them. 10 years ago, a little bit more than 10 years ago, you would have to have the program, first coded out on a computer, written out and compiled. Then you'd have to, separately load that program onto the robot and then start doing actual tests. And really, it was a really arduous process to make any changes. And even minute changes, you would have to, recode everything. So you would often need a actual robot programming experts to perform this. And now where we've moved from there is in this direction of sort of ease of programming. We've come up with means of writing code a lot easier. It's a lot faster to test things, getting the code on the robot to try things out. We have controllers and pendants with screens now also connected directly to the robot, which we're able to use to program the robot. So it's a lot easier to program and to get data out. And I think a lot of those points we're going to dive into in this talk.
Thank you very much, Brian. And let's expand actually on those tools that are available today. And Haytham, I think at one point you were talking about that when we have the preparation for this panel. And could you please expand on those tools that are available today that make easier that configuration?
Yeah, absolutely. And before we talk about today, maybe a little bit of some of those tools that helped.
Yes, of course.
In the past. So I'd like to start with the teach pendant, right? Which is kind of, everybody who's program robots knows about teach pendant. Is kind of the screwdriver, if you will, of the robot engineer. But that has traditionally been kind of the easiest way to program a robot, depending on the application, obviously. If it's a simple, pick and place application, the easiest way is really to teach pendant, teach it where it needs to pick the place, where it needs to drop the place, and maybe a couple of points in between if you need to follow a specific path. So traditionally, that has been the easiest. But a lot of things have evolved since then. So, Brian talked about some of the tools. So today we have more and more of pre-canned functionality, out-of-the-box solution that the robot manufacturers provide for specific applications. So if you're doing kind of traditional palletizing application, pick and place application, you can have those canned functionality together with the HMI screens as well to make it easier. And more and more, there's kind of evolution towards that low-code, no-code type of applications as well. So with the introduction of the smart pendants, again today, you can start using that and configuring, almost like playing with the smartphone type of thing. So you have apps that you can load into the smart pendant. You can program it with the function blocks, not writing any code. And then kind of the latest generation is more towards use of AI and AR as well. So there's some solutions out there that you can, through a tablet, point and shoot type of functionality where the application is smart enough to recognize a robot, to recognize the work that needs to be done, and then through easy configuration from the user, can automatically generate the code for that task. So a lot of tools that happen. The other part as well is that those virtual environments, simulation tools are present there as well, again, with some canned functionalities as well that users can, even without the physical robot, be able to define different scenarios, and this kind of things, automatically generate code from there as well, if needed. Again, in the safety of a virtual environment, not breaking anything, and just working on optimizing their code from there as well.
Perfect. Thank you, Hayden. Now, we talk about programming robots. However, many companies need to repurpose those robots. So how easy, and this question probably goes for Aaron, how easy is to reconfigure those robots to kind of repurpose it for different tasks on a manufacturing facility?
I mean, the good news is, as already laid out, is that there are much easier tools because, yeah, a lot of us, we cut our teeth on those teach pendants, and those are still somewhat intimidating to a lot of folks. A lot of us have those flashbacks to our calculus classes and our big old scientific computer when we see some of these teach pendants now. But the whole thing is, it is getting much easier. A lot of the OEMs that are deploying robots now into the field are using very much more friendly interaction tools, HMIs. We're seeing the rise of the low code, no code options that are out there that are very similar to what kids have been learning in school with like programs like Scratch from MIT. We're actually starting to see those concepts enter into the programming field. And I've seen some folks that literally have never seen a robot in their life. And within just a couple hours or a couple days, depending on what they're trying to reprogram the robot to do, they can actually pick up this knowledge and reprogram the robot themselves. And the days of that programming expert that has to be flown in and to fix it and adjust it can actually be done by the people on the floor, or now even an option of the programmer remoting into the robot to help make those code changes to assist that. So the tools are very much becoming much more friendly. It's something you have to look at, though, as you're designing your system. How easy is it going to be to reconfigure? So we've talked about this in the past about just it's not as easy as just buy a robot. Ask these other questions like this. How easy will it be for my team to reprogram this robot if I need to make a change?
Thank you, Aaron. Now, you mentioned this like really easy way to do things, and now I'm thinking about augmented reality and virtual reality. And then we have a really nice conversation yesterday about this topic, about virtual reality and how it's used. And I'm wondering if there is a role here for virtual reality. And I want our audience to understand how is virtual reality and augmented reality helping here in this area?
Was that for me?
Yeah, sorry, Dean. Yeah.
Sorry, I didn't catch that. Thank you. Yeah, when you start to think about augmented reality and virtual reality and what that brings to the table, think about, even though we're better than we used to be on safety side of things, we now don't have to have people putting their hands in areas that they don't have to be. We could train on a robot without them having to actually utilize that resource. So I don't have to take a robot out of a system or off of the floor. I could train on that aspect of it and then use, as we transition to working on the manufacturing floor, you can then use augmented reality to illustrate where hazard points are, what is the range of motion it should work in, and you can overlay that through augmented. There's a lot of possibilities here, and they expand more and more every day. And that's really the exciting part of how we're going to be integrating in the future with these tools.
Fantastic. Thank you very much, Dean. Now, one thing that we haven't touched, and I want to ask Mark, is the maintenance part of the robots. So we have seen how easy it is to deal with them, interact, but maintenance is also a key and fundamental issue for the owners of these robots. So what are those technologies that are available today to kind of be proactive on this sense, Mark?
Yeah, well, robots today require far less maintenance, I think, than what they used to 20 or 30 years ago. There's been a lot of advancements in lubrication. It's primarily where the core of the maintenance on the actual robot arm is. There's been a lot of advances in lubrication. So there's lubes. There's also things on the robot arm that need to be maintained, such as the robot dressings. Another very key point to maintenance would be where the rubber hits the road. So on the end effector, part touching type details. But again, the applications require typically some level of preventative maintenance. And there's been a lot of advances in welding guns, cap adapters, things of that nature. So maintenance can be done quicker, faster on the outside of the arms or outside of the weld guns. So there's not a need to really disassemble something to do maintenance. As mentioned earlier, robot safeties, previously that plays a big part in maintenance. Previously, lockout, tagout, shutting down a system, shutting down a line to do a simple maintenance was a normal activity. With some of the new safety, software safety features, shutting down one robot at a time or one application at a time for maintenance activities is really the norm. So I would say that's probably the biggest advancement is programmable safeties and how they interact with regular maintenance.
Fantastic. Thank you, Aaron. And we will touch base on safety a little bit later when we start talking about the risk involved in automation in companies. But it is good that we have now set the kind of the baseline on how easy it has become to configure these robots and get information from them, even maintain the robots in a proactive way. It makes me wonder, what is the role for the integrator then? Are integrators going to disappear? Do we need them anymore? So this question is for the whole panel, and I'm happy if more than one actually answered that question.
I can jump in.
Go ahead, Mark.
So as Comau, I'm in a unique position because we supply robots. We're a robot manufacturer, but we're also a very large integrator. So it's a curveball of a question. I wasn't really ready for, but I feel that's okay. I like it. I feel like I need to jump in. This is really good conversation. So, the questions earlier about how simplifying robots and how there's advancements in technologies to simplify how robots are used. That's spot on. They are a lot easier. And as a robot manufacturer, we've added features to redeploy robots such as software wizards, right? So you get an out-of-the-box robot that shows up, and it may be used and deployed for spot welding, the first 5 years of its life cycle, and the next 5 years, it may be a material handling robot and repurposed. So from a robot manufacturer perspective, these wizards can be used. So when you redeploy a robot, you answer a series of questions during the software load. Is it a material handling? Are you using Ethernet? Are you using DeviceNet? You answer these yes/no type questions, and we have templates that are scripted that trigger, let's say, the configuration for those applications or those interfaces. That type of input is usually done by an integrator. The end users sometimes have that level of understanding how many bits, how many bytes, those types of answers to questions as you're entering it. The end user, of course, can do it, but it's something typically an integrator would do. An integrator would be the expert in the application, an expert in the deployment, and the expert in the reuse of the robot. An integrator also plays a very key role in designing not just the robot and the software, but the process. How many robots do you need? The placement of the robots. What size welding gun you need? Do you need an 80 kVA transformer or a 100 kVA transformer? Those types of questions early on in the process will save you a lot of money in making sure you're not under or overbuying the automation, and then also ensuring you have the right tool to do the job. Not all robots are the same. Not all welding guns are the same. And, when it comes to floor space, robot, range, field of motion, all those things are very important early on because floor space is also money. So you want to make sure you have the right tool for the job. You want to make sure that you are maximizing your floor space. You need to make sure that you're designing a system with the mean time to repair and mean time between failure that let's say the end user is expecting. And those are considerations that need to take place right up front that typically an integrator helps with.
Mark,
go ahead, Ethan.
Yeah, no, I mean, Mark definitely brings up some very good points. We talked maybe about optimization, right? So you can definitely, if you don't have a lot of experience in robotics, you can probably make a robot work these days, but is it optimized, right? Are you optimizing floor space? Are you optimizing cycle time? That kind of thing. So here's where the expertise of a system integrator can really help optimize those. But another point as well is that even though the applications are simplified today for the quote-unquote traditional application, things that have been done, we're seeing robotics being applied to completely new different domains, new application as I go, and those are kind of virgin territory, right? So if probably you won't find some canned application that you can reuse, so you have to create your own programming, and that's where some of the system integrator help can really bring a lot of value there as well.
I'd like to chime in on that too. Is an integrator provides a secondary function, which is coordinator. And I think a lot of times companies buy robot and they have a machine. Well, they have these too, but they haven't thought through from a safety standpoint, from an operational standpoint, how are these two communicating? Now, it's one thing to talk about communication, about protocols and communication levels, but there still has to be levels of safety that have to be integrated. There still has to be an operational function. Since I do a lot of these around stamping presses, it is one thing to replace a robot arm and waste $250,000 in spare parts that when you don't have a process worked out. It's another thing to replace one of these. And that's one of the most important aspects is what is a robot function is it can do high risk places where it's operating, but you also want to make sure that you're not creating an issue. We've had lots of cases in the metal forming industry where people have been trapped between robots and walls, trapped between a robot and a machine. It has to be thought through, and that's another value added that integrators / coordinators need to be involved in. And I can't emphasize that enough to people that if you're going to undertake this, you need to understand all the parameters that are going to happen. It's one thing to program a robot so that it doesn't go in this area, but even when I go in, I could still come out and hit somebody. There's a lot of things that you have to take into account. And it's really vital to make sure you do that on the front end. As Mark had mentioned, it's really important.
Yeah, when you were talking about the stamping or metal forming industry, I just have all these things that are going off in my mind because we've seen robots being not only trapping humans, but we've seen applications where robots have been trapped in a press. And if you can imagine a giant stamping press just obliterating a robot arm, it's happened, and it's happened in the past. Now, again, there's a lot of new features and software functions that are there. That are available to prevent those types of issues. But it takes somebody that's done it before, somebody that knows all of the tools that are available to make sure you have the right tool deployed for that particular application. And I think, that's really where the expertise of an integrator comes in.
Wow, that's great. And actually, you have made a good case for integrators. And now I have a question to follow on this thing. So, does that mean that the whole responsibility goes to the integrator when it comes to safety in the deployment? And Aaron, probably that's a question for you.
Yeah, I mean, when you bring in an integrator, you are trying to make sure that, as Dean pointed out earlier, that you have that expertise that they will design and then build your application not only to be efficient and maximized, but also to be safe. There are numerous standards that integrators have to really follow to ensure that they are building that. And they are going to be the primary person or organization that's going to do your first risk assessment. And I say first risk assessment because, as already pointed out by Mark, things might change. Things might be repurposed. Well, you got to redo your risk assessment. And I think this also then brings up the next point. When does the potential end user become the integrator themselves? And this is starting to happen. And it goes back to what Mark pointed out, is that we are seeing applications being repurposed or robots being changed out. When you change any aspect of an application, from the arm to the end effector to what it is using or moving around, you have to re-look at your risk assessment to make sure, did you really look over all these changes you made? Because any change, we all know, can have an impact on everything from performance to safety. So it's very critical that you redo that risk assessment. So integrators, I think, are always going to be around because they have that expert knowledge, but we are starting to see where end users are starting to enter that integrator world themselves. And there are numerous large companies I can think of that are both integrators and the end users of their product. Mostly a lot of the automotive companies are to both sides of the shop. So these are the kinds of things that you need to explore, but there are very clear standards and even in some countries regulations that integrators have to follow. So having an integrator on board is a very good first step to make sure, especially if you're entering this robotics journey, have a good integrator with you along the journey.
Fantastic. Well, thank you very much, Aaron. Now, before we move on to kind of start talking about more about safety and risk assessment, I want to also know what is the role of a hot technology now, artificial intelligence. Like we have seen all the marvelous things that artificial intelligence is doing now. I mean, ChatGPT has brought to the common public the power of artificial intelligence. So I'd like to ask the panel, what is the role of artificial intelligence now in the interaction with robotics?
Yeah, I mean, I don't mind jumping in to begin. I think certainly we might see from an HMI point of view where we have kind of speech being converted into instructions, really. And we could imagine a case where the user simply instructs the robot what to do via speech, and you have some kind of plugin, some kind of ChatGPT type plugin, which can convert that speech, I guess, firstly into text, and then the text into actual instructions that would need to be taken out. I mean, and AI in general, certainly we've seen that a lot with things like computer vision applications. So having an AI or a model, AI trained model that can help you recognize parts and find, the outline of a part, such that that side of, automatically finding that part and picking it can be achieved via this computer vision, which is powered by AI. So those are just some examples that, at least in my mind, immediately come to the fore.
Yeah, definitely, Brian. Yeah. I was just going to say, I agree with that. There's definitely a great use of AI, because if you have different parts of varying shapes and forms, and it's sometimes very difficult to pick them up. So having an AI that can determine the best way to pick those up is definitely great. And then, I think it's going to permeate a lot of different areas. I think it's becoming more of okay, let's tell the system what the outcome should be, rather than programming the system for a specific functionality. And that can also include interaction between different robots. So if you have a fleet of mobile robots, for example, using AI can definitely help coordinate all the different tasks or different robots as they work together. And I think that's just the beginning of the things that we can do with artificial intelligence and robotics.
Wow, sounds fantastic. Mm-hmm. Now, we have seen how easy it is now then to set up these machines and even use the power of new technologies to like virtual reality, artificial intelligence to help us do that. But make a task easier comes with some challenges as well. I bet before, when only a few experts could program these robots, they were somehow the gateway to access them. So in some ways, they were safe by obscurity. Like it was hard for anyone to do changes. So what other challenges are now like this easiness of programming robots are bringing to manufacturers, and how manufacturers can deal with that? That's a question for the whole team. Like if anyone wants to jump and start.
Oh, I suppose I can jump in first. Hopefully,
Sure.
there's some other additional points that can be made. But no, you're spot on. So now that a lot of the interfaces have touch screens, they're very simple to navigate, point and click type interfaces. The responsibility again of an integrator is to make sure that it's not easy or simple to make a change that would cause some type of safety issue. Now, it's also the end user's responsibility going through risk assessments, but there shouldn't be, that's one risk, right? Where somebody can make an easy change that could cause damage to something. But there's additional levels of security that can be added. One of the things that we generally will do is create user logins per person. For a particular robot, let's say, for example, and those are handed out once the proper training has taken place. So if we know, Bob on first shift has the possibility of potentially interfacing with a robot, Bob's trained, Bob has a username, Bob has a password. So when Bob logs in, he's allowed to make a certain number of changes, certain type of changes, and those changes are logged in a log file. So we know, number one, who made the change, that they were trained, they were qualified. And then number two, we have the ability to track changes and understand what was changed, what time it was changed, and hopefully why it was changed.
Perfect. Thank you, Mark. Anyone else? Well, I guess interacting with like that interaction, those controls help. What about cybersecurity? Have anyone thought about the cybersecurity issue, like remotely accessing robots?
Yeah, I mean, I would say, a robot, when it comes to security, cybersecurity side, it's very much the same as for just any computer, really. From a certain point of view, a robot is really a computer with a bunch of sensors and actuators connected to it, right? And the same security points that you put in place, the same measures that you take for just any computer, that can just be extended to a robot. So as long as that the computer of the robot is safe, in the sense that you can't have people getting unwanted access, hackers, whatever it might be. As long as that's safe, you can then consider, at least from a cybersecurity point of view, it's safe. So it's really about applying the same principles you would apply to any computer system and computer network as well.
Perfect.
Any computer, but also any manufacturing space as well. So there's a multi-level kind of cybersecurity defense, obviously going from preventing unauthorized access on the shop floor to all the way to firewalls and this kind of thing. So I think the same principles apply also for robots.
Thank you. Now we have seen then how easy it could be to implement robots today and the role that integrators still play. We have talked about training for the users, like for them to know actually how to move around that. How about the whole integration with the rest of the system? I mean, that's the labor of the integrator you have mentioned, that is to make sure that the robot works well. But how does the integrator also make sure that the robot can easily communicate and interact with other parts of the systems, even with those ones that don't belong to the robotic system?
Yeah, that's a very good question. So we mentioned already a number of them already. So safety kind of is one of the top priority, obviously making sure that, no matter how simple the programming is, it still has to be safe, right? So whether it's secure the perimeter or, as Dina was mentioning, kind of making sure that going into a specific zone and coming out of them still remains secure. So that's definitely number one. For the rest, the integration with the rest of the automation and the machine is also getting simpler. We have standard communication protocols now, whether it's on Ethernet IP or the rest. Most of the robot manufacturers also provide connectivity to the PLC machine control with dedicated interfaces or function blocks as well to facilitate that communication and synchronization as well. The last piece is really making sure that because the robot doesn't operate on its own most of the time, it still needs to synchronize with the rest of the operation. So there is some kind of a synchronization mechanism there that needs to happen. And those are all things that the system integrator can definitely support and build as they integrate that robot or robot cell within the rest of the machine.
Fantastic. Thank you, Hayden. Go ahead.
I got to jump in for one more thing.
Sure.
I've been recently a part of a lot of recent trade shows. I know Haytham's Rockwell, and he's probably not going to say this, but I have to. There's a whole network of partners, distribution partners in the U.S., for example. I think that's where we're all from right now. It's like a hub of bunch of different automation tools, light screens, push buttons, PLCs, robots. So, if you're looking to have a system built, connecting yourself with a good partner, a distribution partner of industrial automation equipment, going to that one resource, that one company, they'll ensure that your light screens are the right ones to work with your PLC, with your robot, with your valve manifold, all those things. There's a lot of what they call connected solutions nowadays, where it's more plug and play, and things are happy to work in an environment together. And it's a very important and key part of being successful.
Thank you, Mark. Now, of course, after this conversation, we know clearly how easy it is to interact with robots, how easy it is to bring robots into the factory floor. So it makes me kind of wonder why we don't see that robots everywhere yet. Like, where that kind of roadblocks still out there towards robotics? Like, what's the issue that some manufacturers see, and how would you kind of address that? What would you tell them? And that's probably a question that I wanted to ask Aaron, as there was a conversation about probably hostility around robots. Like, I don't know if the word is hostility, but Aaron, better about that. Yes.
Yeah. I mean, I think everybody has their own item that's holding them back. It's almost on a case-by-case basis. When you talk to the small and medium guys, it is a lot of just questions about investment. How much money is this going to cost me? What am I looking on training and all this? So that's their biggest fear. Now, the great thing is we're starting to see financial models like robots as a service come into play to address some of those concerns. Then you start working up the chain of other concerns that we see out there. And just like what Mark pointed out, there are a lot of integration questions. Well, how am I going to have this device talk to this device to talk to this device? A lot of folks are still using brownfield sites. They have their old equipment still around. They don't really want to give that stuff up sometimes. So how do you bring that to bear? And Mark already pointed out some great solutions to that. I would also add that we are starting to see some interoperability standards come to play from here in the United States. The team in Boston at Mass Robotics has come up with a very good communication protocol that I actually got to test in a previous life prior to joining ASTM, where we did integrate multiple mobile robots, arms, PLC controllers, lighting systems all together using those kind of protocols. There's also in Germany the VDA 5050 standard, and it's showing some great promise too on how to orchestrate large fleets of mixed types of robots to complete tasks. So all of these are coming to bear to address some of these concerns. It's just, how do we in the industry help address those concerns and help encourage more robots to be deployed, because I think that is what we're at right now. Is we're to the point of the technology is great and can address a lot of this, but how do we here in the industry help the potential end users that are starting their journey or halfway through their journey to really keep going and help them show how they can address these financial concerns, integration concerns, and training concerns, because the solutions are there. It's just we got to show them that they exist.
Fantastic. Thank you, Aaron. Go ahead, Mark. You want to say something?
Yeah, I can add. I mean, I think your answer is spot on. I also think a lot of companies look at the most complicated application potentially and trying to, let's say, eliminate that. And sometimes that's hard. And if it's hard for a human to do, sometimes it's hard for a robot to do. And a lot of time companies will look at that application and then overlook some of the dull, some of the dirty, some of the dangerous jobs that a human's doing, when those are really the simple, let's say the slow ball pitch type applications for a robot. And some of the more complicated ones, you may end up needing a human to continue to do for a while.
That's true. Well, Dino, were you going to say something?
I was going to add to that.
Sure. Go ahead.
When you look at some of these applications, and I think Mark's spot on, is that companies will overanalyze it. And that's how they talk themselves out of using a robot. Working with robots around press brakes, I see it all the time where they look at all their jobs. They say, well, they pick the worst one. They say, okay, what about this one? Okay, let's eliminate that one. What if I can solve 90% of your problems by this solution? Well, let's focus on that 90%. We'll worry about the 10% and finding a solution there, but let's focus on the 90% that we are solving. If I'm keeping the number one machine for injuries in the U.S. is, to the best of my knowledge, still press brakes. And press brake injuries, there's over 1 a day amputation. And so with those kinds of numbers, if I can reduce that by half by using robots to load and unload parts or to manipulate, it's really a no-brainer if you can, because as I said earlier, it's tough to replace one of these.
True. Well, we have just a few minutes left, and I want to hear from each of you. What do you think the future looks like for robotic interaction with robots? And if you could say a minute or less answer to that. And I want to start with you, Dean, now that you just spoke about that. So
I think that when we look at where robots are currently, especially with the mobile units, the opportunities are there to do more and more roles. If we can get rid of some of these high risk environments where robots can provide a solution for it, that will help us so much in our pursuit of keeping manufacturing here in the U.S. Speaking from the U.S. standpoint, a lot of what triggers people to move things outside is risks. And there are other countries that don't look at risk in the same way.
Thank you, Dean. Aaron?
Yeah, I would just add on that, as I think we're going to start seeing these technologies continue to improve. I think we're going to have much easier low-code, no-code solutions being provided so folks can make a lot of changes. I definitely see that we're going to have AI start playing a bigger role in that, and that'll be a very interesting path. And also, I would say we're going to start seeing more robots entering educational programs to help bridge some of these gaps. One of the great things that we see is that kids pick up this kind of technology really quick. And now that you pretty much can operate a robot from your phone, and we all know kids are great on their iPhones and their Android devices, I think we're going to start seeing a lot more robots and interactions in the classroom to prepare the workforce going forward. And it's because we're going to have easier interaction tools available to help train these folks.
Thank you, Aaron. Brian?
Yeah, I think, we mentioned earlier a bit about augmented reality and virtual reality. I think, as we go towards this no-code scenario, I think the virtual reality could be an even easier way of programming, maybe the easiest. you can imagine the user puts on a pair of goggles, has maybe a controller in each hand, and sees a sort of simulated representation of the robot, and probably also augmented, so with maybe tables and a box with parts in it, whatever else is in the environment. The user can then move around, change, look at different views, and then move the robot using the controllers, really refine the movement, the path, perfect it, and then of course save that path, and then eventually load that onto the robot. And you've already seen the movement in the simulation. You've seen how that's going to work, so you're really happy with that. So that I don't know. It's hard to imagine it getting much easier than that.
That's true. Thank you, Brian. Hayden?
Yeah, for me, mobility and autonomy are kind of very powerful. And it all stems from, what we just discussed about AI and the rest, but really, having more robots working alongside the humans in a more collaborative way, whether they're fixed or mobile. And just being able to understand and do the task themselves without the humans having to program all of that is really, really powerful combination. And I think you'll see more proliferation as they become more intelligent and easier to deploy and cheaper to deploy, obviously. So.
Thank you, Hayden. And probably the hardest part, Mark, after everybody has said everything. So,
yeah, I agree with everybody. So I'll come up with maybe a little bit different of a spin. Sure. I think everybody's spot on. I think also that robots being controlled with one CPU that has the ability to do everything everybody described is where we're going together, at least with Comau and Rockwell. Where we have what we're calling unified control, meaning one brain controlling your conveyors, controlling your robot arms, to really simplify the programming, reduce the number of skill sets needed on a shop floor, making it easier for an integrator or an end user to make changes, to customize things, and less, let's say, skills to teach somebody. They learn one and they can do all. So that's where we're going. That's where I see it going. And I think everybody here had really good answers to that question.
Well, thank you, Mark, and thank you to all of you. Fortunately, we reached the end of the time that we had for the discussion. Now it is the time to hear from our audience. So we have received a series of questions. We will pick a few of them to answer it now. And so let's go and take a look at the question that we have received, and we'll be back in a few minutes. So Katie, back to you.
All right, gentlemen, thank you all for that great presentation. As Edgar mentioned, we are going to move into the question and answer session. If you have a question for us today, please go ahead and enter it into the Q&A window and hit submit. We will get to as many questions as we can. If we do not have time for your question, do not worry. We will reach out to you following today's session. So Edgar, I'm going to pass things back to you and the group to answer some of our attendees' questions.
Thank you, Katie. So we have selected 3 questions from our audience to be answered in the panel today. All other questions will be answered via email or through other ways. So the first one says, how common is hand guidance for training robotics? Is this going to be niche, or will we see it become widespread for most robotic applications?
Yeah, I'll answer this one, Edgar. Yeah, that's a good question. I mean, at the moment, it is quite niche, but I definitely think it's going to become more widespread. It's just another method of this easy programming. So, I mean, what we typically see is a kind of a 6 degree of freedom force torque sensor in the end of the robot, just before the end effector. And by grabbing hold of that, the user grabs hold of that and is able to kind of push and pull and twist the robot, and move it by that means. Of course, what's very important, it's very important to emphasize that this is strictly for cobots, right? You're not going to see this with industrial robots. They're simply too powerful, too fast. It's simply too dangerous. But at least within the cobot realm, this could become quite a popular way of programming. I mean, we typically see, in addition to the force torque sensor, you might have a couple buttons, maybe 2 buttons, So maybe one to start recording, stop recording, and another one to start playing and stop playing. So the user would start the recording, move the arm around as desired in the desired path, stop the recording, and then there you have it. There you have some path planning saved and taught to the robot. Definitely within the cobot realm, this is going to become more widespread. But of course, cobots only make up sort of a certain percentage of all robots. So.
Yeah, and I add to this with what Brian already said. I think it is right now a niche market, but we're starting to see some applications that are really great about how to expand into more of this. A lot of new companies that are like doing automated welding are using that hand-guided one so that the welder can actually teach the robot, this is the weld pattern you will follow. And they use the hand-guided method. So that means that if you could do that in welding, then what's the next application? Maybe gluing is the next one you could do hand-guiding kind of motions with, or even inspections of a part, where you have a robot that's moving a camera around a part to inspect it. Well, you might have to use the hand-guided feature to actually move the robot around and get those recordings done, as Brian pointed out, of hit record, do your hand guiding around the part, hit stop, now you're off and going. So I think it's going to turn into something great. It's just we got to match those with the right applications.
The next question from our audience says, how can we incorporate vision systems more completely into robotics?
I'd be happy to take that, Edgar. It's a very good question, because one of the challenges we have currently, when we talked about it earlier, is how does an integrator better perform their job for making sure that it's safe for the direction that a robot is traveling? How do we make sure that the range of motion is okay? Well, with vision systems, we can now see some of the hazards, and we can outline where some of those hazards are. And we can then take, using like things like AI or even just simple programming, where we're anticipating what we're going to be doing and the end effector, because that's also part of it. As I try and move the part in and out, is the end effector going to hit a wall? Is it going to hit its own body of the robot? Is it going to hit the machine it's going into? There's a lot of different applications here where a vision system can be used for that, but also verify, is the part held correctly? Is it being manipulated? And is it the right part?
Yeah, if I could add, vision systems they can be used for many different things. Part inspection, robot guidance, things of that nature, along with some of the applications Dean has mentioned. And there's been a lot of development in the interface between the robots and the vision systems. For example, when decking a part, or decking, let's say, a piece of glass into a vehicle's windshield opening, previously there was a lot of setup using laser trackers, different devices to calibrate the vision system's frame to the robot's frame. A lot of that stuff is automatic nowadays, where you mount the sensors on the robot. There's an interface that's already loaded in the robot, software in the vision system where you can simply hit a button, and the frame alignment between the robots and the vision system is done through a series of automatic movements with the robot, which makes the application so much simpler and easier for the end user to deploy. So there's a ton of advancements and a lot of different types of vision systems that can be deployed on robots very easily.
Thank you, Dean and Mark, for answering the question. And our last question says, what are some of the potential downsides of using AI in robotics?
I can answer that, Edgar. That's a very good question, right? So AI is not going to be the answer for everything. So first of all, it takes a lot of effort to create an application with AI that works very well. So you going to see it being done for applications that are frequently used, right? So if you have one type of application, the effort to train an AI system to do that application will be much greater than just programming it from the first place, right? So that we need to be aware of, right now, at least, we're not in a situation where, the AI can teach itself to do everything, right? So there's a lot of limitation there. But the other part as well is that if the AI is not well trained, we don't know what some circumstances happen that would make it behave completely different than the expectation, right? So even though we have a model and an AI that works very effectively, we'll still have to have some, how should I say, some kind of containment or some kind of monitoring to make sure that if someone foreseen signals doesn't happen, at least it doesn't, have create bad situations or unsafe situations, right? So there's a lot of things that go into there as well.
Fantastic. Well, thank you, Hayden, for answering that question. And thank you, and Aaron and Dean, Mark and Brian, for being here today, sharing your time, knowledge, and experience with our audience. Thanks to our audience for joining this conversation, this discussion, and I hope you enjoyed and found it as valuable as we did. And also, we're grateful to Rockwell and their staff of experts who are doing their part to bring smart manufacturing into our reality in each passing day. And finally, for globalspec.com, thank you to the million of technical professional engineers who have allowed us to connect them to the parts and services they need for project success. And now back to you, Katie.
And thank you, Edgar. Now, just a few items before we end things today. I would like to say a huge thank you to all of the panelists today and to Edgar for leading our discussion. And a special thank you to Rockwell Automation for sponsoring this Realizing the Potential of Industrial Robots series. Today was the last session of our 4-part series. Please join us for the rest of our sessions. You can visit our series page using the link listed in the resource widget. Sign up for all the sessions today. You won't want to miss it. And one last thank you to our audience members for being here with all of us today. You will be receiving an email from us with a link to the on-demand version of this presentation. You will be able to come back and watch this again or share it with colleagues. Again, thank you for taking time to attend this Global Spec Series event. Take care, and we will speak with you soon.